So this is the virtual lab for the hydrocarbons. Part 1 would be the model lab, so you're going to play with the model, but part 2 would be the virtual lab. Part 2, properties of hydrocarbons. We're going to study the solubility and the density of those organic compounds. We have 3 test tubes here. There's just water in there. We're going to add heptane, 1-hexene, and toluene in number 1, number 2, number 3 test tube. So this is a heptane, number 1. So I'm going to add some. Number 2, 1-hexene. So add some. And number 3, toluene. Okay. Now I'm going to shake it to see if it's going to dissolve in water. So this I can shake. Okay, just leave it there. So now you can see they have a very clear boundary still. Okay, after I shaking it. And also, this small amount is the whatever I added organic compound, and it's floating on the top. So that's the observation. You can, based on the observation, answer questions on the report. Okay. Now let's move to part B. Chemical reactions of those hydrocarbons. Okay, now we have number 1, 2, 3, 4 test tubes. I'm going to add, respectively, into those test tubes the reagent according to the lab menu. Okay, I'm going to do one at a time, and you're going to observe the reaction. So first, let's do the number 1, heptane. It's about 10 drops, heptane. Okay. So now I needed to turn off the light because this first reaction should be in the dark, so I cannot be very bright area. So I'm going to show you the result. Okay, it's a little dark here. Now I'm going to add 3 drops of the 1% bromine into it. Okay, now I want you first to look at the color of the reactant. Heptane, colorless. Bromine, this bright orange-red color. Okay, so that would be, if we mix them, either if there's no reaction, you should see the mixture of the 2 colors should be a little diluted brown color or a little yellowish color. That means there's no reaction. Be careful. Don't think this is the reactant. This is also reactant. So the mixture should be some kind of reddish color if there's no reaction. Okay. If there's a reaction, this color should be gone, disappear. Okay. So now let's check if this heptane will react with bromine. So I'm going to add 3 drops. 1, 2, 3. Okay, so you can see in the dark against the white thing. You can see there's a little orange color in there, right? It's diluted, of course. It's not as dark as this. Okay, it's diluted, but that means this color still in there. There's no reaction. So since there's no reaction, we needed to continue. So if this color resisted, add 2 crystal of the aluminum. See, the color stays, okay? And I'm going to add some crystal in there. Shake it. See if the color will disappear. Just add a shake for 20 seconds. So I'm going to shake for a while. So you can see the color still like that. Okay, now if this is still resisted, we needed to put this under the light to see if the light will trigger the reaction. So I'm going to get closer and let's shake it and see if the color will disappear. or get lighted, maybe not completely disappear. This should get very close to the light source. What do you think the color will take a longer time to react? What I'm expecting is under the sunlight, maybe the light is not bright enough. Under the sunlight, it should be some reaction in there. Okay, to get rid of the color of the chromium. It will take quite a long time. Okay, we'll leave it there. Maybe we'll check later. Just the first one, we'll check the color. Okay, now let's move to the 1-hexane. Okay, another family of the compound. Add some. Okay. Now again, we're going to first add the bromine. Okay. Now let's see if the color will, the red color will disappear. Let's check. It's gone. This color is really, really light. Okay, so if this is already reacted, we don't need to continue. Okay, let's see, this one's almost colorless. Okay, now let's move to the toluene, another family. Add bromine first to see if the reactor is this red color bromine. This color resistant. Okay, so you can see the brownish color in there, even though it's diluted. Okay, now let's try to add the aluminum chloride. Yeah, the discharge of the color will be the indication of the reaction. First we need to shake for 20 seconds. We need to really shake it, let it react. It's been a while, so the first one heptane, not much change, so pretty much not much of the reaction. The second one, we've already saw that once we add bromine, the color will disappear. This one was a little bit orange now. After we add aluminum chloride, it's become more yellowish. See that? The brown, reddish color discharge a little. So that's the three. And this one would be our mystery. So we're going to check the mystery to see the observation. So later we're going to use the observation to decide this one's belong to which family, because that's three different families. Okay. So now let me add a bromine to it. 3 drops. Let's see what's happening. So I'm going to add our mystery yet. Red color stuff, the bromine into it, now you can see it's gone, right? So we already have some idea what's this unknown one, mystery liquid is. Okay. Now we're going to do more tests family compound, and then we'll try the mystery liquid. Okay. So this is number 1, heptane. Number 2, 1-hexane. This is the toluene. This is the mystery one. So this time we're going to add potassium permanganate. This color, originally this color is a very beautiful purple color. You can see that. Okay. Okay. 3 drops in each one. 2 drops, 3 drops. All right. Take a look at it. I need to shake it. You can see the colors, the purple color, purple color, purple color. If the purple color gone change to some other color, that means it's reacted. So let's shake each one for a while and then see the color change of the purple. Already happening. First one, let me shake again. Check the color. Second one. Check the color. Third one. Second one. So this one's still purple. Second one is a little brownish color in there. This one's still purple. This one's brownish color. Okay, so that's a different reaction with the potassium permanganate. So based on that, write down all the observation and find out the mystery compounds family.